I'm Nina Buffi. I'm the CTO at OSPIN, a small biotech company based in Berlin. What we are doing at OSPIN, we are developing a modular platform to automate and digitize biologists and more generally scientists' work. Taken from a more software perspective, what we are doing is we are creating a programming language to manipulate cells. Now, I believe that to understand a bit more concretely what we are doing, we have to start with some biology concepts. So, people that work with cells usually do or perform or develop what is called a bioprocess. So a bioprocess is nothing else that I have some cells in a state A, and I would like these cells to be in a state B. And this A to B can be quite different depending on the application, on the cells that you're using, and so on. And also, there can be many steps between this state A and state B, or just a few. It really depends, right? And an example of bioprocess could be that I have a small amount of cells and I would like to have a larger amount of cells, which is called an expansion process. Or another example could be, you probably heard about stem cells, like these cells that can in principle become any other type of cells, right? So an example of bioprocess could be I have some stem cells and I would like to differentiate them in, for instance, muscle cells or fat cells. And this differentiation process is also what is called a bioprocess. Okay, now at OSPIN we say we want to automate bioprocess. So if you ever enter a biology lab, or maybe you even worked in a biology lab, you would be like, it's astonishing to see how much like they're still working manually. They're leaving like pipetting stuff and moving liquid, feeding cells, crazy stories about biologists going on a Saturday night to feed their cells. So at OSPIN we say, this needs to be automated. So we basically want a machine where the biologist can just put his cells into the machine, and then, of course, you have to configure the machine, tell the machine what to do, and then the machine does everything automatically. So why do we want to do that? Well, because when you try to do something manually, well, first of all, we are human beings, so we just do mistakes when you do stuff manually. And also, if you ever try to do a same thing like the same thing exactly the same, it doesn't really work. As human beings, we'd always do it slightly different. That leads to really a low reproducibility. And also, like a manual approach usually leads to higher costs compared to an automated process. On top of that, we believe that biologists should really concentrate on the biology and not on, again, pipetting stuff, doing manual work and so on. They should really have the time to concentrate and to think about a bioprocess, what they want to do, and to develop that idea, and not, again, pipetting all day. However, so we want a machine to be automated. However, we don't want to lose on this path to automation, we don't want to lose flexibility. There are two reasons for that. So the first one is that we want a machine for bioprocessing. And we have seen that bioprocesses can be quite different one from another. So now if you want to have a universal platform machine, this machine needs to be flexible so that if somebody is doing a certain type of bioprocess, the machine can adapt to that bioprocess. If somebody else is doing another type of bioprocess, the machine can also adapt. But the other reason is also that during a bioprocess development, so development in every field means that I start with something and I don't really know how it's going to look like in a few steps later. So I want actually a machine that can adapt to what I'm trying to do, so that if after a few trials I realize, actually I would need that, then the machine can adapt to it. More concretely, if I'm working on a machine, I realize after a while, I would need this extra sensor, this extra thing, that the machine should allow that, should be modular in the sense of flexible. So the key message here is we need a machine which is automated, but at the same time flexible. And now is, of course, the question, how do we achieve that? So at OSPIN, we created what we call bioprocessing modules. A bioprocessing module is nothing else than a functional building block composed of a hardware, software, and mechanical component. And every bioprocessing module has a different function, a function that usually or might be needed in a bioprocess. For example, we have bioprocessing module that pumps on liquid, or bioprocessing module to measure pH, or a bioprocessing module to control the pH, or to observe the cells, which is kind of a microscope, or a bioprocessing module where the cells like to be, which is then a cell chamber. So now we have these different modules, and how do we get to a machine from that? And this is shown in the next slide. So on your left, you see a drawing of the machine that you actually have on your right. And you probably, on the left, you can recognize a few of the modules that I was showing you before. You can see probably there are like, you can recognize the 4 pumps. You can see a module to measure the pH, a module to control the temperature, a module to measure the glucose. And there is really, like, I try to really make the one-to-one correspondence between the drawing on the right, on the left, and the picture on the right. And I won't enter here too much into details about like what the machine does. It's more interesting probably for a biologist. The idea is here is a machine with which you can cultivate cells. So since you can control a certain number of parameters as pH, glucose, and so on, you can control what basically your cells are doing. The cells are on the bottom of the image in this glass that you see, kind of red. The cells will be in there, and then they are shaked. We'll see later what exactly that means. So the cells are shaked, and so they are happy. And so with such a machine, you can basically grow cells in there. But the point here is not really what the machine does. It's more to realize, okay, we have some modules, and by combining this module in a certain way, we can create, for instance, this machine. But if I combine the same set of modules in a different way, or if I use different modules, then I can create completely different machines. Basically, we are creating a sort of Lego for bioprocessing. As like with Legos, you can, with the pieces, you can create, I don't know, a dinosaur, a princess, a house. Here we say, okay, with this bioprocessing module, we can really create bioreactors or machine that are tailored on the bioprocess that biologists or scientists would like to do. And we also argue that you can modify the machine while you are developing your process. If you realize, now I would like to have a 4th pump, or I would like to have an extra sensor, you can just add it to the machine. We're really working hard to get there. And maybe now is a nice moment to basically, you can maybe at some point play around with that. So I don't know, I think the resolution is not the best one, but we created once what we call a bioprocess configuration, so that the people can just drag and drop the modules on the grid here and basically create their own bioreactors. So you can visit you can go to the address and try to create your bioreactor yourself. This is super useful for biologists because they really think in terms of their cells, and they don't really have a feeling of how the machine should look like. And with this tool, by just drag and drop, maybe I need something to heat up my cells, or maybe I need something to measure the oxygen, so on. By dragging and dropping, they really realize what they actually need. All right. Yes. So, and of course, you could argue, but you develop a few modules, and what if I need an extra module? And it's also true that, well, we are a company of 15 people. We are limited in like the development we can do and the production we can do. But even if we would be a company of, I don't know, 100 people or 1,000 people, the demand of new modules, the ideas out there is always bigger than what a company can possibly do. So we say we want to be able to integrate modules of other company, research group, and so on in our platform. And I make you an example. So we have a partnership with a university in Erlangen, which is in south of Germany. They basically developed a setup to observe the cells. So they took a camera and a motor, and they basically built a setup which is a microscope, a cheaper version of a microscope, which is cool. But now, if you want to sell it, well, this thing just does one thing. So either you really need a cheap microscope, or you don't buy it. However, if this setup is part of a whole platform, and you say, okay, maybe I need a microscope, and I can also add to it a pump or a pH sensor or whatever, then suddenly it becomes way more interesting. That's why for them it's interesting to hook up their module into our platform. And for us, of course, it's cool because, well, we can offer a wider range of bioprocessing module, and we can eventually have more customers and cover more use cases. So far about the hardware and the mechanical part maybe. Now I think comes a part that is more interesting for us today, which is the software part of our platform, and actually how do we control our platform. So as you probably have realized by taking a look at the picture I showed you until now, our device don't have any screen. So we control our devices with a browser-based user interface, so that the user can just like use his browser and then visit our page and then control the machine from that. And all this, the data that are produced by the machine, like sensoric data or configuration and stuff like that, are stored in a cloud. And how does it work? So we have seen that our machines are composed out of modules, right? So let's assume that I have this machine here that is drawn here physically. So then if my machine has, for instance, let's take the example, a pH controller, well, I will see this same pH controller in my user interface. So I have one-to-one correspondence between the physical modules that are in the machine and the list that I see here in my UI. Now, how can I control the machine? How can I configure it? So for every module that we have in the machine, we can basically set every module. What does it mean, setting a module? It's like, let's assume a module is temperature control. Then the obvious thing is I can set the temperature I want in my machine. Or if the module is a pH controller, then I can set the pH I want in my machine. And so on. I can do that basically for every modules that I have. And I set this value, and then I say these values are true for instance, a certain duration. Here in the example is 48 minutes. Or I can say are true until I click on a certain button. Now, this thing of having like setting the different values for the different modules and having kind of an exit condition, this is what we call a phase. And if you think of it in programming language, having this phase is nothing else by having a block, a code block, where you can set your variable, and then you want a condition to access this block, that in this case is either a trigger kind of, or a timer. So let's say after a while, you have to exit from, in this example, this while loop. So nice, we start to have some code blocks. Now, I want to run a program. So a code block is not enough to run a program. How we can do that? Well, we can simply create more phases, so having more code blocks. So if you take the example again of the pH controller, it means that in the first phase, I can, for instance, say, the pH should be 7. And then in the second phase, say, oh, my pH now should be 7.4. And I can do, of course, this for all modules that I have in my machine. Like if I have a pump, I can set the speed of the pump, say, I don't know, 50 RPMs in the first phase, and then 20 RPMs in the second one, and so on. So by having these different phases, these different blocks, and then since I can go from one phase to the other by having this time-based or trigger condition, then I can just execute basically for the biologists is bioprocess, in terms of programming language, more my program. Now, we are kind of getting there to have kind of a programming language, but still, well, you say, yeah, you can set some variable, you have a program execution, but it's still not quite a programming language. What are we missing? So first of all, we are missing the ability to set condition on variable. It's something that you usually do when you are programming. You say, if that variable is bigger than that, then do this, and so on. So this is something that we're still missing. And what we're also still missing here is the fact that in programming, you also have nonlinear execution of a program. You have forks, you have loops, stuff like that. And it's exactly what we are working on right now. So we are working on this condition and on this like nonlinear execution of a program. In more details, what we are doing is the following. So we want to allow to have conditions on every variable. Every variable means every variable that makes sense in terms of the machine, in the sense that if I have a pH controller, yeah, I have a variable called pH. But if I don't have a glucose sensor, I cannot really have a variable called glucose concentration, of course. But for the variables that make sense in the context of the machine, we want to be able to set conditions. If we take the example here, we want to be able to say, okay, I want to switch to the next phase if my pH is 7.4. Now, since it's a physical system, it doesn't make sense to say just, if it hits 7.4, it doesn't really make sense because it can be kind of a random thing. If you want to make sure that your pH is stable, then you say, okay, if my pH is, in this case, between 7.3 and 7.5 for at least 150 seconds, if this is the case, then switch to the next phase. And the idea is that we want this to be able for every variable in the machine. So the cell density or the temperature and so on. And being able to doing that is nothing else than in programming just reading a variable and saying, okay, if the value of the variable is that, then do this. If the value of the variable is something else, then do that, and so on. And if we have conditions on our variable, then it's also easy to fork the program execution, because I can say, okay, if the pH is that for at least this amount of time, then go to phase 2 in this example. If I don't know, in 2 hours I didn't reach this pH, then do something else. Or something that makes more sense in terms of biological thinking would be, if my cell density reaches a certain value, then detach the cell from the surface, otherwise just go on feed them, for example. And what we also want to introduce in our user interface is the ability to have loops, that I can say this phase or this group of phase should run 3 times, 4 times, whatever, as a for loop that you usually use. So, and I really believe when we reach this point where we, as we already have, we can set a variable, we have these code blocks, and then we have conditions, and we can, for the program execution or loop it, then it's basically a programming language for biologists in the context of our machine, of course, but they can then program whatever bioprocess basically they want. And of course, now we were talking about like programming a process and so the configurations that the machine runs. Then, of course, what you do, since everything is automated, you click on the button start, and then the machine just starts. And once the machine is started, then it starts producing data, because the machine has some sensors in there and produces some data. And every data, or for every sensor, we have a graphs that show the value of the data. And on the x-axis, well, you see the time, kind of obvious. And I think that's now, it's the right moment to try something live with you guys. So let's see if my experiment works. So, yes. So what you see on the screen there is our user interface. So you have here ospinapp.devices. So here we are logged in with my account, so we can see the devices I have access to. So you see that there are 3 that are gray and 2 that are red here. The 2 that are red means that they are connected to, they are online, they are connected to our web application, and so they are ready to be used. Now, there is this device here that is called 006 Berlin, is a device that is currently in our office in Berlin. So what I'm trying to do with you, or I want to show you how does it work, we can try to create a process here and try to let the machine in Berlin run. So how do we do that? We just click here, build process. Then let's change the name with something nicer. All right. So here you see, as I was showing in the presentation, here you see a list of the modules that are physical in the machine. So the machine has some pumps to pump some medium, basically to give some food to the cells. That are the purpose of these pumps. We have some temperature controller to control the temperature in the machine. We have a glucose sensor because we want to know if the cells have enough to eat or not. And we have a shaker. This thing that I was telling you is to shake the cells, because the cells like to be, this kind of cells for this kind of customer like to be shaked. And then we have a pH controller. You also, when you are a biologist, you always want to control the pH value of your cells. Now we can start programming something. So we can start, I think the most fun thing to see later is the shaker. So we can start by setting a speed of a shaker. So we can say, well, in the next phase, we would like to shake the cells with 30 RPM. Sounds good enough. Then, well, the temperature, I think we can leave just 37 degrees. Here, just like we have 3 temperature controllers in the machine. That's why you see 3 times. And we can also run some pumps just for the fun of it. Just put 0 here. And so on. And the concept is that, well, if then we say, okay, we want to shake the cell with 30 RPM for, I don't know, 5 minutes, or we say, well, actually we can say manually, and then we want to decide ourselves when we want to switch, we want to change the speed. So we just go here then, and we add a new phase. And we say, well, in this new phase, actually, we would like to shake the cells with, I don't know, a bit, let's do a bit faster, 70 RPMs. And so on. And I can change, of course, now, I don't want to make it too long. Of course, here I can say I can change all the other modules, not only the shaker. Now, we are almost ready. I could add other phases, but let's just do it 2. Now, I'm ready to click on start, so the machine should just do what I told the machine to do. And we have a video here, or we are connected through video to our office here. I can Yes, exactly. So here you see the machine that is physically in Berlin. Now I'm gonna try to start a process, and we should see that this shaker thing that is here, you can see your mouse, yeah. So that the shaker here, it should start moving. So let's go back once, and let's start it. And let's see if everything crashes or if it does work actually. Yes, very good. And you see, yeah, that is running. Yeah, and we can also try to move to the next phase and see if actually it goes a bit faster as we programmed. Yes. Yes, it moves a bit faster. All right. And, well, and you can also see here we have this data viewer. Every sensor and actuator delivers data. So for instance, we can see here, we have just as an example, the temperature sensor, which is delivering data. Well, of course, now it's heating up slowly. It's going up because we said that we want it 37 degrees. So it's slowly getting a bit hotter. And so on. So here, all the sensors in the machine, they have their own graph and are displayed here. Okay, I think you got a feeling of what the machine is capable to do. Let's just stop the process so that, and let's see. Yes, it stopped. So everything's fine. So we just managed to run the machine, which is good. All right. And another thing that we really badly want to offer to our customer, our users, is the following. Now, I explained you that we have these different modules, right? And this module, you can see them as independent. Like, okay, I have a pump, I have a sensor, and that's it. But you could you could start thinking, can I combine them? Can I do something higher functionality? Can I do something cooler out of it? I'll make you an example. Let's assume you have a pump and you have a glucose sensor. You could see, well, it's a pump, it pumps liquid, and I have a glucose sensor, it measures glucose, fine. But I could start thinking, yeah, maybe I combine the two. So maybe I can connect my pump to, for instance, glucose reservoir. And then I can measure my glucose concentration with my glucose sensor. And then I can tell the pump to turn faster if my glucose concentration goes down, or to slow down if my glucose concentration is too high, right? And I can basically build a glucose controller out of it. And we want basically our user to be able to do that in the interface, so that they can really like draw this line and connect modules together to create what we call higher functionality. So there are functionalities which are a combination of lower functionalities. And of course, the UI would adapt to it automatically, in the sense that if I only have this pump and this glucose sensor, which are like not connected at all to each other, well, then I would only see in my UI, I would only see, like, I could only set my glucose pump speed, right? Because they don't have anything to do. I can just set the speed of the pump and the glucose sensor. Well, I just see the data, that's all. But if I have a glucose controller, then the UI should show, well, you can set actually the glucose concentration now, because you have a controller out of it. It's not anymore just a pump and just a glucose sensor. You can really, with this, you can really control your glucose concentration. So in the UI, you can set, I want actually in the machine a concentration of 10 millimole of glucose, for example. And we also would like to, that the user itself, of course, is a question like which algorithm is run by this controller. If you know something about controller theories, you can use different controller type to just control this. You can have a PID controller, a 2-points controller. At some point, we would love to allow our user to basically write their own algorithm, that they can say, yeah, I want a controller, but I even want to take over and say which controller should run in there. Or we can just code it ourselves and then offer different possibility to our user. This is also a possibility. And so why we believe this is so cool, or why do we like it and we believe in it? It's because basically cells are a living system. If you talk to any biologist, we'll always say, like, yeah, they never behave exactly the same. Even if you're exactly doing the same thing sincere, it can always happen that they just do something that they're not supposed to do, is slightly different. So in that sense, it's a good idea to introduce some intelligence into the system, or to be able to interact or to react to what is happening in your experiment, and not just like if your cells don't follow what they are supposed to do, while you screw up your experiment. It's a bit like, I like this analogy, like we said that a bioprocess is like from state A to state B. The analogy you could do is the following, like let's assume I want to drive from Berlin to Hamburg, and I want to program my car to drive me there. I don't want to drive, I just want to sleep, and I want to program my car. Now, I can program my car in such a way that it always takes the same street, the same path, the same street to go to Hamburg. But if at some point there is some traffic, or a road is closed, or whatever, then I just take, instead of taking 2 hours, I like take 5, 6, or whatever. I never arrived in Hamburg. While if I put something in my programming so that I can react to what happened, well, I can use Google Maps, say, okay, yeah, there is traffic on that line, on this road, let's take the other one. This is a bit the same thing, just being able to react and to put some intelligence in the system so that the experiment can react to the external conditions. That's it. All right, any questions?
that you won't create a critical state or something like that if you let users from the outside control the environment. So
okay, I'm not sure. So you're basically saying that if we give control to biologists, that they could come up with crazy stuff. Yeah, it is absolutely true. So one of the things that we are planning and we have to do is to put some like a sanity check and stuff. With the example I was showing with the glucose and the pump, of course you could start doing crazy stuff and connecting a pump with, I don't know, a heater or whatever. It doesn't make any sense. So of course you have to do some checks there and like make sure that what the user is trying to do, at least it's not dangerous or whatever. That you have to find the boundaries, of course, between like what you want to allow and what you don't want to. Yeah, that's true.
Do your conditions only have access to current values of sensors and stuff, or can they also look up old data? Like how was the temperature yesterday?
That's a good one. So when I'm thinking about it, I'm more thinking about like current data. Like okay, easy example. Right now, since we don't have it, this conditions is like, I know that more or less the system reaches 37 degrees after, I don't know, 3 hours. And so I set the phase to last for 3 hours. If I would have this condition, I could just set, okay, if my temperature sensor reaches 37, then switch to the next phase. So in that sense, it's more like the current value. But of course, you can come up with fancy thing. And if you think like, or for an application, it depending on the old data, it cannot make sense to take decision the day after. We could build it in. I mean, we have access to all data. That is totally possible. Maybe you could combine old data with new data. I cannot like now come up with like an example that biologically kind of makes sense that I know an application for that, but why not? We do have competitors. I mean, there are other companies that do bioreactors. So like these machines are, from a biological point of view, are called bioreactors. And there are a few even big companies that do that. We believe, or like our strong point is to say our UI, it's easy to use. It's very intuitive, which is not the case, at least this is at least my opinion, from like the UI that I saw from other brands and stuff. And especially, we also, like, one of our strong points is also this modularity and this flexibility that others have, but maybe not to that extent. For them, it's more like, yeah, if you want an extra sensor, you can add it, but you cannot really add everything. So we do have competitors, but also we have strong point where we can like compete, so to say, yeah. Yes?
I assume it's highly local, the programming, what you can program on a sort of bioreactor is highly local to what sensors or how you configure it basically. So if I be a biologist and get started with it, I probably want to set up my machine first. So what's the latency to, you need to, I guess, hand build it according to the layout, or is this also automated?
So no, I mean, maybe I can go back to here. So basically, when we deliver a machine, it looks like that. So it's already everything pre-configured. So it's the biologist that doesn't. So when the machine, so let's assume a potential customer come to us and say, yeah, we would like something like this, okay? Then we build it and we deliver this thing. So for us to build it, 1-2 weeks, depends. Depends, it's like, it totally depends if you like only ask for stuff that we already have, like modules that are already in there, and it's, then in 1 week we can do it. If it's something more fancy, you need some special something and so on, which we also do, then it might take longer because there is some development time into that, but yeah. We badly want to. We want to do it, yes. We didn't, I mean, the company is still kind of young, and like the simulation was not the first priority, but it's something that is definitely something we want to do, yes. Yep.
How much will this machine cost? Because I know people that work in the lab, and it's exactly like you said, they have to do so many manual steps, and it takes days and weeks.
Yeah.
And what they say is the biggest factor why they do not automate those steps is because it costs so much to buy a machine like yours.
Yeah. Well, so let's put it like that. It of course depends. It of course depends on like the sensors that you have in there and how complex the machine is. But to give you a rough idea, it's between 30,000 and 60,000, something like that. Then if you really want something super fancy that we don't have, you have to put development inside can be even more expensive, but that's more or less the range. And it's of course true that in the biology lab, maybe they don't have the money. What they usually do, they write this grant application where they say, yeah, we need the money to buy this thing, and then usually at some point I get it through. Yes?
Why are there so many manual steps involved in the whole process? Isn't there some kind of standard, ISO standard or something where this could be automated?
You mean like that I need to configure manual the process? So you mean if you cannot have a standard process or something?
Yes, so for me it sounds like there have to be a person who needs to connect to this pipe with this and so on. Isn't there something that you can do which a robot is something doing for you? So
Well,
you don't have
I know what you mean. So we have to make a distinction here. Like most of our customers until now, they are more like research people, like they work in research and research group in university, and there they are really like still playing around. If you take the image here, they are still playing around with tubing, something like that, because they are still like trying to figure it out what they need, right? So they still like, maybe I move this tubing there, or if the tubing's a bit shorter, maybe it works better, and this kind of thing. So for them, it's kind of good that they still have this manual thing of trying out, because automating something that like you don't really know what you want to do it doesn't really work in this context. But of course you are right. If you go more like an industrial way, or where you exactly know what you want, then it's relevant what you are saying. We have actually, it's funny because we are working on a proposal for a project, and it was exactly this question, like, oh, we need so many tubings and stuff, and we need to find a way to basically have it already prepared, and like we need to minimize the time somebody has to take to like put the tubings on the machine and so on. So your question is definitely relevant. It's something we have to kind of solve, but more for like later stage and not like for research, what we are mainly doing right now. Yes?
So if I understood correctly, the service you provide is that you build a machine, you deliver the machine, and you provide like a backend, so to say, in which you can configure, and the machine will communicate with that backend.
Yeah, so it's like the UI, so the web application is included in the machine. So we sell the machine, and you have also access to our web application. You don't like have to pay something extra. Like the two are coupled together, because it doesn't make sense otherwise, because you cannot use the machine. Of course, in the future, if you have some fancy feature that not everybody uses, then we could think of like making people pay to use this advanced feature. But for now, that we have like what we have is the basics to use the machine, then it's just included in the machine, so to say. So yeah, okay, so the firmware, well, like, yeah, the firmware on the microcontroller is on, yes, it's already on the machine, yes. Yes?
the picture you showed us before, like with the machine in your office in Berlin.
Yes.
Is that the standard size? Did you ever build a bigger machine like that?
So this is kind of it's this one, right? So this is kind of I would say standard size that we usually, but we don't want to be bound to this. Like this size comes from the fact that usually in the biology lab, they have some desks that are certain size. So we try to make sure that it fits that size, right? But for instance, what we are also working on bigger machine. For instance, what we are doing, we are hooking up to our web application machine from another company, and there is a machine that is like it's bigger than that, or like they have a 2-liter machine that we're working on now, and then they have a 20-liter and 200-liter, so that we could scale up basically, but we are not doing the mechanics ourselves, so we are just doing the electronics and the software, and we let them build the mechanics, so to say, yeah. Yes?
Have you explored other visual programming paradigms, like Scratch, for example?
No.
How big is your team?
We are 15. 14. Yes?
How would you handle downtimes in the machine?
Sorry?
How would you handle downtimes in the machine? So if the program gets interrupted at some point accidentally or it overloads?
So what?
You're handling a dangerous substance or something.
So the most critical thing in here is the following: if since we are communicating, so the most critical thing here is that you lose internet connection. This is the most critical thing that can happen, because of course our customers are super scared that their data get lost. So what we do is simply that basically by default we always save our data on, we have a Raspberry Pi inside, okay? So we just save the data on the Raspberry Pi, and when there is internet connection, the Raspberry Pi uploads the data to the cloud. If the internet connection is not there, it just stores the data. And the SD card is so big that, well, you will really need to don't have internet for many days before you run into trouble. So that's what we do.
So the logic itself is stored on the local machine?
Sorry, I didn't understand.
That the transition from one phase to another phase, this is stored locally in the machine and not
What basically happens is that, well, you configure your process, and then you send down what we call a process description to the machine, and which is a JSON file, and then the machine parses it and then save the different phases in the machine. So yeah. Yes.
Are the customers able to customize the machines locally? So if they turns out they need another
Yeah.
something?
Let's put it in this way. Yes, we are working to make the user experience a bit better. So usually what happens like now, that in some cases we are able to just ship the stuff and they can do by themselves, but usually we need a Skype call to instruct them how to do it. So this is something we are trying to improve, but it's definitely a goal. So it's possible, but you need some user that, like, they're not afraid of a screwdriver, so to say. Yeah. All right. Yes.
The cloud access, is that a feature or is it necessity?
Sorry.
You said there's a Raspberry Pi in there,
Yes.
so it should be able to run a web server by itself, so you can access it locally without the cloud access connection. Is this possible, or is the access only over the cloud, even if the machine is right next to you or your computer?
Well, but honestly, I know what we are using is like, because of the feature uses and the database where we have to store the stuff and so on, we are using Amazon Web Services, just because it just like provides everything we need. Like also in terms of, like, you have to imagine that you have to like store all the data this machine produce. We have to store into the database, and there's also this question like how you fetch back the data from the database to display them and so on. And like with Amazon Web Services, like, I'm not the expert here about the web application, but it provides us like the tools to do so. So for sure you can come up with a solution, but it's like a simple or a relatively simple one that support us to do what we want to do. Yes.
If you have scientists in your team that know how to program, can they currently program their own little modules, or are they stuck to the UI?
So no, how does it work is the following. So the module, basically you program it, you don't even need kind of you don't need a UI for that, because you just program. So we have microcontrollers in there, right? So let's assume that you want to hook up, I don't know, a sensor that is not in the machine, right? So what you need to do is just like, we are using C++, you have to write the code to read your sensor, and then you just like basically in a configuration file, you just tell the machine, you just say to the UI, there is this extra module that is called like this and like that, and as this, you send a description basically saying what it can do, and then the UI automatically know that there is this that there is no new module or new sensor, and the UI doesn't have to do anything. So it's totally handled on the microcontroller or Raspberry Pi side, depends. Yeah. Yes.
I wonder if there is the demand to again customize this machine, and if this is on your roadmap to build like a live machine, if you can customize it in the web interface, and the blocks are like robots control or something.
So the key here is like, or not the challenge maybe here is what we want is the following. So if the customers say, now I would like this module. So what we need to make sure is that we can just ship the module, and then he can just build it in, and then he doesn't have to do anything on the web app side, so that the machine just recognizes, okay, there is a new module, and just like send a new process description to the UI, and the customer doesn't have to do anything on it on his side. What we want the user to change was this higher functionality thing where you can combine functionality. This is something where we want them to modify something, but the experience itself of like integrating new module and so on should be really as plug and play as possible, so that they don't have to do anything on their end. Also because usually they are not super tech savvy. So there are a few people that would like to program around and do things, but most of the people are just like, give me stuff, I just want to use it, and I don't want to bother in like programming something or doing something on this line. All right, then I guess time for a break.